In this example, we are going to try to find the angle between two vectors. And so here is one of our vectors written kind of in the ij form, and this is our other vector. So first thing I may want to do is just to rewrite these. And okay, so those are our two vectors, and if I were to graph them, that is what we're looking at. And so this is vector -5, 12, and this is vector 3, 2, and this is the angle in between that we are looking for. So that is theta. Okay, so we're trying to figure out that angle between them. So it could be quite a bit of work, because maybe we can connect these dots and we can use some, I don't know, find the angle here, find the angle here, and then we could do some math. Actually, we probably wouldn't need that. Anyway, we don't need to do any of that because luckily there is a formula. So the formula for this is cosine of theta is going to equal the dot product between your two vectors divided by the magnitudes. So you're looking at dot product and then you're going to be dividing by the magnitudes. But you're going to be multiplying the magnitudes together. Okay, so that's really the pieces that we need. So we're going to set up our formula. So we're going to be doing cosine of theta. Let me do this different color. We're going to do cosine theta is going to equal the dot product between this and this. And then we're going to divide by the magnitudes. The magnitude of this and this. Okay, so dot product. Dot product is just going to be -5 times 3. So -5 times 3 plus the y values essentially multiplied together, 12 times 2. And then the magnitude is going to be Pythagorean theorem. So you're looking at this distance is -5, this distance is 12. So if I do this math, I'm doing -5 squared plus 12 squared, and we're going to square root it. So there's a formula for it, but basically you can do Pythagorean theorem if you want to. So it's -5 squared, which is 25, plus 12 squared, which is 144. So we're going to be multiplying that value times 3 squared plus 2 squared. So 9 plus 4. All right, and then the top, we have a -15 plus 24. And on the bottom, we're looking at the square root of 169 times the square root of 13. So on the top, we get ourselves a 9. On the bottom, we're getting a 13 square root 13. But we don't need to rationalize anything because let's pull back down what we're actually doing. We are doing now the inverse cosine. So theta is going to be the inverse cosine of whatever that is. So we'll plug that in the calculator, and that gets us an angle of about 78.9 degrees. So if we look at our picture, does that seem reasonable? Yeah, maybe. Kind of looks 90-ish, so a little bit less than that. So it definitely could be about 78.9 degrees. All right, so that was the first example. We're going to do one more, and it's going to refer to something called orthogonal on the next one.